So guys, in the previous video, we were talking about metal displacement reaction, which is already a redox reaction. We know a metal takes a spot of another metal within a salt. If it's more reactive metal, there will be a reaction and you will see a new kind of compound because the more reactive metal obviously oxidizes itself. And the less reactive metal, the one which is lower in the series, becomes a pure metal. It comes out of the salt. It becomes a pure metal and it becomes a zero charge. So copper, lead, silver, they tend to become zero. They want to stay alone. And sodium, potassium, calcium, aluminium, zinc, they want to make salt. So they tend to become more and more positive. And for the colors, even we talked about one of the common color changes, which is a question which is very common in the CI examination, that what happens if copper nitrate reacts with iron or copper nitrate reacts with zinc. For zinc, the color is going to be not pink. Zinc is gray metal, copper is pink metal, and all the other metals are obviously gray as like zinc. Right now we're going to be talking about the idea of oxidizing agents and reducing agents. So we're going to be talking about oxidizing agent and we're going to be talking about a reducing agent. Now it often confuses people because of the terms, but it's not as deceptive as it sounds. Oxidizing agent is a chemical substance, let's call it a chemical substance to make it fancier. Chemical substance that oxidizes others. The name implies, right, that it's an oxidizing agent, so it oxidizes others. The reducing agent is a chemical substance. It's a chemical substance that reduces others. Now what happens is that oxidizing agent is oxidizing others, reducing agent is reducing others. During the reaction, something happens to them as well. And what happens to them is that they themselves participate in the redox reaction. So the oxidizing agent is helping the other ones to oxidize them. It's helping in the oxidation of others, but it ends up reducing itself. It reduces itself. While the reducing agent is helping in the reduction of others, it is a chemical substance that reduces others, but it ends up oxidizing itself. So if a chemical is oxidized, it is actually a reducing agent. If a chemical is reduced, it's the oxidizing agent. For example, let's use another example from metal displacements. Let's suppose I've got zinc sulfate. For example, I have zinc, pure zinc reacting with copper sulfate, because we talked about the idea of colors of copper sulfate in the last video. What happens is copper is more reactive. Copper wants to make a salt. So copper will be like, okay, I want to make a zinc sulfate. And copper will be like, yeah, sure, I'll just separate myself. I'll be alone. What happens is that zinc was initially a 0 because it was a pure element. Then it makes a +2 because obviously it wants to stay with the sulfate. Copper, on the other hand, was the +2 in the beginning, but by the end it becomes a 0. So zinc is increasing its oxidation number like this. The oxidation number of zinc is increasing. So it's kind of oxidation number increase. It is oxidized over here. We know this. It loses electron. It loses electron. For copper, we know that in the beginning, copper was a +2, now it's decreasing to a 0, so oxidation number decreases. It gains electron. ठीक है जी. Now, zinc is oxidized, so zinc is actually the reducing agent. Now this is very important for us to remember. If zinc is oxidized, it's actually the reason for copper to reduce. So zinc is also the reducing agent. Because of the zinc, other ones are getting reduced. And since copper species, or you can say the copper ions, were reduced, it is the oxidizing agent because it is due to them that the zinc is oxidized. So let's make it simple. If something is oxidized, it is the reducing agent. And if something is reduced, it's the oxidizing agent. Oxidizing agent oxidizes others but reduces itself. Reducing agent reduces others and oxidizes itself. Now, the other thing, which is the last thing within the whole chapter, is the idea of color changes for oxidizing and reducing agent test. So when we talk about that test, there's a test for oxidizing agent and there's a test for reducing agent. For oxidizing agent, the test is that you add, let me use the color as well. You add aqueous potassium iodide in the oxidizing agent. If you're testing for an oxidizing agent, you add aqueous potassium iodide, which is obviously Ki, potassium iodide. It changes from colorless to brown. It changes from colorless to brown. So if you add potassium iodide in something and it changes the color from colorless to brown, iska matlab the other chemical that you were dealing with was an oxidizing agent. Now that's a very simple test. You add a chemical which is potassium iodide, just Ki, potassium iodide. The observation is likely to be colorless to brown. If it's colorless to brown, it is an oxidizing agent. The other chemical was an oxidizing agent. The other test is for reducing agent. You add acidified. Acidified means acid has already been added into the chemical. So acidified potassium manganate. Acidified potassium manganate. Now what happens is potassium manganate. If the color changes from purple to colorless, if it's a change from purple to colorless, your chemical is a reducing agent. So if it's a chemical that you don't know anything about, but you add you want to test reducing agent, you add acidified potassium manganate. If the color changes from purple to colorless, then the other chemical is a reducing agent. These are the two chemical changes that you need to know. If it doesn't change the color, if it's not changing from colorless to brown or not from purple to colorless, then the test fails. It's a negative test. So the chemical was not an oxidizing agent, not a reducing agent. But if it gives you a positive result, then it is the agent that you are dealing with. So these are the two color changes that you need to know. And that is, my friends, end of the chapter of redox. I'll be giving a video on past papers, but right now I think that should be enough for you. Take care. Let's catch up for results in obviously the next session. Thanks, guys.